Okay, good afternoon once again. And let me share the screen here. Good. Okay, perfect. So, I realized that I put online the video of last week lecture only today. So I'm sorry for that. I realized today that I forgot to upload it. It's now uploaded, but in any case, you find the videos on the chat of Teams if you want to get them earlier. But now they are available on the YouTube channel and on Virtuale. Do you have any question related to what we discussed last time? Okay, so let's move forward. Before jumping to a more technical description of the design variables for port design, I would like to emphasize once again the important value of beaches, and I would like in particular to discuss now once again the key role of the ecology of beaches. And here you can see a picture of a dune with vegetation over it. This is in particular dune that has been restored, meaning that the equilibrium of dunes is very delicate, and the presence of vegetation is essential for the stability of the dune, and in particular, it gives to the dune the capability to cope with the wind erosion. And in this case, the vegetation of the dune was restored. We will not discuss about restoration of dunes and beaches in general, because it's not really the subject of this program, but I want to emphasize that, as you can see here, the dune is indeed a protection for the land. You can see in the bottom of the figure that there are trees, forests behind the dune in the landward side of the dune, and the presence of the dune and then the vegetation that is an integral part of the dune and protects it is essential for protecting the forest environment, land environment. And this vegetation, as I pointed out last time, it can grow up because there is some fresh water inside the dune. Actually, the sand is characterized by a very high porosity, and therefore, even if the dune is few meters high, but there are some dunes that are reach 20 meters height, but even if the dune is a few meters high, in this picture it looks like it is less than 10 meters, still the dune is capable of storing fresh water in this limited thickness, this limited depth. It's still capable of hosting fresh water and feed the vegetation. In particular, you can see that the type of vegetation is selected, is naturally selected. So there is a transition from grass to trees in the landward side, because of course, over the dune, the availability of fresh water is limited, and therefore the dune typically cannot host trees or other kind of vegetation with deep roots, because of course, immediately beneath the dune, there is salt water, because from the ocean, we have indeed saltwater intrusion into the land. I think we already discussed a little bit saltwater intrusion, and the saltwater intrusion is regulating, in a way, the equilibrium between fresh water and salt water in the underground of the land. And you can see from this picture that indeed saltwater intrudes into the land. Because salt water is also heavier. So you know that fresh water, the weight of fresh water is about 1,000 kilograms per cubic meter. I say about because actually there is some salt even in fresh water, so it's maybe a little bit more than 1,000, but it is conventionally it is assumed that the specific weight of fresh water is 1,000. salt water, seawater, the weight is 1024, so 1,024 kilograms. It may look like a tiny difference. Actually, it makes a big difference in terms of underground pressure, because the pressure exerted by the salt water and the fresh water, of course, is proportional to the self-weight. And then, as I said, it makes a big difference. So the configuration of the equilibrium surface between salt water and fresh water is resembling the shape of a wedge. And indeed, in Italian is cuneo. Indeed, we call it in Italian cuneo salino, and in English is the salt water wedge. Fresh water has the advantage of having the possibility to reach a higher elevation, because the land, of course, is at a higher elevation with respect to the sea. So if there is an adequate flow of groundwater, the fresh water can reach a higher elevation. With an higher elevation, there is more pressure, and therefore the saltwater wedge is pushed back into. Sorry, I forgot to. Just 1 second. Okay, so I had the feeling I forgot to activate the mic. It's okay. So the saltwater wedge is pushed back into the sea if the height of fresh water over the sea level, it is indicated with lowercase h here, is significant. But if we withdraw this fresh water for human consumption, the effect is that we lower the water table, and therefore lowering the freshwater table means that the salt water gets into the land. This intrusion is one of the major concerns for coastal areas nowadays, because once groundwater gets contaminated, the recovery of the groundwater is extremely complicated. In some cases, we adopt screens made by concrete or made by jet piles in order to block the saltwater intrusion. So, as I said, this is a particular concern because in coastal areas, typically there is a strong urbanization, which means limited infiltration, and there is groundwater extraction. So there is less replenishment to groundwater storage, and increased demand, increased withdrawal, which means that we lower the height of this lowercase h elevation of fresh water above sea level. And this is indeed a bit of a problem. Here, the separation between freshwater and saltwater is drawn as a line, as a sudden transition. Actually, there is a dispersion zone where we observe, going from freshwater to saltwater, a progressive increase of salinity. There are models to study these processes. There is a lot of research activity ongoing, precisely because for the very reason that we are concerned by saltwater intrusion in the coastal areas. And so indeed, there is a lot of research on this, on the modeling of the saltwater intrusion. I just want to say that even a small change in the elevation of the water table, the freshwater table, means, as I mentioned last time, a very strong advance of the saltwater wedge landward. So even a small change of sea level means a significant advance of the saltwater wedge. And I mentioned last time that indeed this is a problem of originated by climate change and corresponding sea level rise. Okay, so let's go back to the list of lecture, and let's move to the next one, forcing estimation. So forcing estimation is a classical problem in engineering. Let me just check if I can expand here. And let me see if I got the figures. Yes, it seems that I'm getting it. Just 1 second. It's port planning and environmental impact. I'm sorry. And let me see if I get the figures. Yes, there are the figures here. Okay, so port planning and environmental impact. So what is the first step of any design project? Is the estimation of the forcing. And with forcing, I also mean the expected traffic for a port, the expected function for a port. Also, I mean with forcing estimation, the estimation of the wind forcing, wave forcing, and the forcing from the lands, because typically, in order to build a port, what we do is to protrude, as I said last time, the land into the sea with some artificial structures. And these artificial structures receive a load from the land. They receive a load from the sea, but also they receive a load from the land. You remember that we discussed, I showed you some of the most important projects that are ongoing or recently completed in terms of port construction. And you remember these artificial structures protruding for a long distance into the sea. Typically, they are like walls that delimit a bucket, and the bucket is filled with soil in order to get this extension of the land. What is the purpose? The purpose is to reach with a vertical structure a sufficient depth of the ocean to allow the ships to berth. Berth means that a ship approaches the port and gets moored to it. Moored means fixed. So berth, once again, is the structure of the port, and it is the structure, the artificial structure that we design and build. And the mooring points are the points where the ship is anchored. Okay. We will discuss more about terminology in what comes next. So, as I said, the first steps are the estimation of the loads, which is preceded by planning, of course, and consultations with the stakeholders, because I mentioned the estimation of the traffic, of the requirements in terms of goods, in terms of number of ships that are expected to berth, and these requirements, these traffic estimates need to be predicted based on the consultation with the stakeholders. The stakeholders are what we call in Italian portatori di interesse, means the entities that have an interest in the construction of the port. So, of course, one stakeholder is the port authority, who knows the expected traffic. Other stakeholders may be the industries, who have demands in terms of receiving essential materials for their activity, and need to displace their products, to commerce their products and ship them along the oceans to the final destination. This planning and the consultancy with the stakeholders is an essential activity, which has to be organized with proper advance, because typically when you intervene on the environment and you design hard structures like ports, you also involve stakeholders who are concerned by the construction of the infrastructure of the port. They are concerned, for instance, by the environmental impact. They are concerned by the impact on tourism. They are concerned by the noise. They are concerned by contamination of seawater and therefore contamination of the coast. And typically, these are at all effects stakeholders, and are stakeholders who may, as I said, be concerned, may have a lot of reservations, and finally they may oppose to the construction of the infrastructure. And therefore the consultation is not so easy. Now we have for the construction of big infrastructures in Italy, this consultation with stakeholders is compulsory, is imposed by the laws in force, precisely for the need to make sure that the intervention on the environment is carried out in a transparent way, with the proper consultation of all the people who have interest, a positive interest, but also concerns. So this, you have to refer to the laws in force, to the regulations, in order to understand how this consultation is to be carried out, what is the timing, because the laws in force prescribe a minimum time lapse between the start and the closure of the consultation. They also tell you how to manage the suggestions that were received. Usually, it's not a task of the engineer to organize and manage these consultations. These bureaucratic steps usually are not a task by the engineers, but are rather a task of the administration behind the initiative, behind the construction. I'm sorry, give me 1 second because this call I need to reply. Pronto? Sì. Sì, guardi, io purtroppo adesso sto lavorando, me ne sto prendendo cura, però non sono ancora pronto. Mi dispiace, adesso non riesco a darle ulteriori informazioni perché sto facendo lezione. D'accordo? No, no, non c'è problema. Grazie, buongiorno. Okay, I apologize because usually I don't reply phone calls, but this one was I couldn't skip it. So as I said, it's the administration. So typically there is a municipality, a public administration that promotes the construction of the port. The public administration may provide to the technical design with internal resources. This is very rare in Italy. Or the public administration may involve, may delegate an engineer, typically a professional, to make the design project, to elaborate the design project. And usually these calls are made through public calls, not just with direct assignment. If the amount of the project is, if the resources involved are very limited, it may be also direct assignment, but usually it is a public call. But of course, all of these rules depends on the country, on the state regulations, and usually it's the administration taking care of it. In some of the cases, engineers, when they work together into societies, organized societies, they may decide to hire a lawyer who is an expert in these public works, if they feel that they also need some internal support. But usually it's not really a task of the engineer, even if it is very useful for you to know where the information can be taken. And as in other cases, you have to refer to the national regulations. And the national regulation, you can find them either by consulting an administration or looking by yourself. There are, in some of the cases, guidelines on the web which guide you over the full process. And if you don't have a clear definition of your obligations by the laws in force, by the national regulations, you should look for guidelines, because remember that when your work is evaluated, they also evaluate if you follow the best practices. And the best practices are, first of all, the laws in force, and you are obliged to respect them. But if there are guidelines given by international authorities or given by educational academies, you are required to follow also these guidelines. And therefore, you have to look at the national regulation, but also the guidelines, especially those that are technical guidelines that are close to your to your task, to your job that you have to carry out. So the preliminary load estimation and preliminary design is an essential step, and we will start discussing of this. Also, essential steps are the environmental impact assessment, and in particular, the requirements for the environmental impact assessment, once again, they are dictated by the state regulations, laws in force, or guidelines. In some of the cases, you are required by law to make an environmental impact assessment, typically when the impact of the infrastructure is expected to be large. In some of the cases, when the intervention is really very small, and therefore the impact is negligible, you may not be required to do that. But in most of the cases, with big projects, this is an important step. And then you produce a preliminary project, and then the preliminary project, at least in Italy, a preliminary project, we are required to do that. The preliminary project is approved. Keep in mind that the legislation is continuously changed. So here, I did not include what was recently introduced, a requirement that was recently introduced by the Italian legislation. So before preparing the preliminary project, we are now required to study competing alternatives in order to make sure that there was a proper evaluation of multiple solutions. And this is something indeed important. When you intervene over the environment, when you build infrastructures, when you suspect that there is indeed an environmental impact, now the laws in force require that you evaluate competing alternatives. So alternatives. One alternative may be no intervention, and then you make a cost-benefit analysis. Cost-benefit, which can be performed in economic terms, but also in different terms, because money is not the only one concept. There are some impacts that cannot be monetized. And therefore, you may have the requirement to study the no intervention alternative and intervention at different scales, large structure, intermediate structure, smaller structure, and make a cost-benefit analysis. This is not included here. And then you come up with a preliminary design. And then the preliminary design is approved, evaluated, and approved by the authorities, which give you the green light to go on with executive design. And actually, there might be also a third step. So final design and executive design, which means that at any step, you provide more and more information, more and more technical details in order to finally get your detailed project. So it is important to know what is requiring the law for you, for instance, to perform the preliminary project. It is important because you have to save your resources. The preliminary project cannot be very detailed because it means that it costs a lot. Keep in mind that cost for a design project is, of course, proportional to the overall cost of the structure. May be very relevant because the cost for the design project may be something like 10% total cost of, or let's say 2%, 3%, depending also on the amount, the total cost of the intervention. So it is really a key cost. And therefore, it's important that in the preliminary project, we produce only the information that is required and no more than that. Okay, let me just see, because I have a PowerPoint presentation here. I'm not sure I already got it. No, I don't think so. Just 1 second. What happens here? Let me see. Okay, good. Got it. Okay. Good. Okay. So load estimation, and let's start with the birds. Once again, here you get rigorous definition of what is a berth. It is a structure in ports and harbors where a vessel may be moored, usually for the purpose of loading and unloading goods and passengers. So let me open another web browser and let's search for berth and let's see some pictures. Okay, you see some examples. So, for instance, here, you see a sketch. So the berth is the part of the structure where you find the mooring points. And let me see, like the one that you see here. So we may have two different types of berths. One is the pier. This is, for instance, an example of a very simple pier. Or let's go on Wikipedia. This is not simple, and you see a pier here. And I got some, the picture here is interesting. 1 second. Okay, anyway, as you see here, there is a very simple pier, and another type of berth is the wharf. The wharf is aligned with the coastline. Okay, you can search some pictures. Here it's a little bit more problematic because searching for wharf gives a lot of results. And closing some of the, okay. And so the wharf is aligned with the coastline. The pier typically is more or less perpendicular to the coastline. So let's go back to our definition here. And so it's a structure where a vessel may be moored. Let's look at a picture of mooring points. Okay, this is a typical mooring point for a ship. This seems to be located over a wharf, but I'm not really sure. Not really sure. And this is another example of a mooring point. You understand that these mooring points convey to the berth a significant load, because once that the ship is moored, the ship is moored because to avoid that it moves. And the ship may move for the action of waves or wind. So these actions basically bring a lot of load over the mooring points. So on the one hand, you have to estimate these loads, which depend mainly from wave forcing and wind forcing. On the other hand, of course, the mooring point has to be anchored at the structure in a proper way. And this is typically an engineering problem. Okay. Now, berths usually are managed by a responsible body like a port authority. Usually they are public structures. Of course, if you have a private port, usually private ports are very small. Private ports are not managed by a public authority. But if the port is relevant, typically there is a public authority. And in any case, when the port is relevant, even if it was private, the law enforcement may impose the creation of a responsible authority, which has to take the responsibility of managing the safety, the security of the traffic. Okay, so what are the loads that we have to estimate? Let's try to make a classification. As usual, classification is useful because it helps us to gain a better understanding of what we are talking about. So we may classify the loads in first into three categories, depending on the origin of these loads. So we may distinguish between loads from the seaside, loads on the berth structure, and loads from the land side. I think it is quite clear what are the loads from the seaside and the loads from the land side, like the action of the soil, self-weight of the soil that is pushing from the land to the structure. What are the loads on the berth structure? For instance, the trucks which get into the berth, approach the ship, and also they break. When they break, you understand there are some loads which are originated directly from the berth structure. Or another example is the load of the cranes. I think you know better than me what cranes are, but let me give you a picture. Just 1 second. When I have many windows open, I get lost. Okay, now I am okay. Okay, these are the cranes. And they are essential for moving the loads into the sea. Okay, they can be fixed to the berth structure, or in a way, or moving. They can be positioned over a truck, they can move, or they can be fixed or semi-fixed. Okay, good. We can also divide the loads into two very important categories: the normal loads and the extreme loads, also called accidental loads or live loads. What is the difference? The difference is that the normal loads are those that are acting over the structure for most of the time. The extreme loads typically are much larger than the normal loads and are exceptional, and therefore, given that they are exceptional, they are infrequent. So the extreme load may be given by extreme wind. Extreme wind is infrequent by definition, so it's not very frequent. If it is an extreme, it is very rare, and otherwise it wouldn't be an extreme. Another extreme load may be due to wave forcing, extreme waves. Another extreme load may be due, for instance, by a truck that is braking very quickly, like to avoid an accident. So the truck gets into the berth at a too high speed, and then needs to brake suddenly. This may be an extreme load. It's not a normal load. It's originated by an unpredictable event. Or another extreme load may be given by an accident between two trucks, which originates forcing over the structure of the berth that is exceptional. So normal loads, given that they are very frequent, are also likely to be concurrent, occurring at the same time. Extreme loads, one has to be very unlucky to get them at the same time. And therefore, when we design, given that any engineering design cannot be too conservative, cannot be excessively conservative, we have to evaluate when we design what is the probability of two extreme loads occurring at the same time. We will discuss this. First, let me explain why in engineering design, of course, it's a trivial consideration, but let me explain why in engineering design cannot be too conservative. The reason is that a conservative project, besides requiring more money, because of course you need to make a stronger structure, a larger structure, whatever it is, it requires more resources. The problem is also the environmental impact. The environmental impact of an infrastructure is proportional to its size. So if we put a lot of iron into the concrete, it means that there is an increased cost, and there is also an increased, for instance, CO2 emission related to the transportation of this iron. And you may think something like this is not very relevant, but indeed, it also requires more work, a longer time to construct the structure, which means environmental impact, because during the construction time, you have a higher environmental impact than in normal times. And therefore, for these considerations, you cannot oversize. And if you oversize, usually it's not a good project. Of course, you cannot run the risk of being not conservative, but you can never be also too conservative. And therefore, you cannot assume that extreme loads occur altogether in order to stay on the safe side. You have to really evaluate the probability. What is the probability of getting a strong wind and a track accident over the berth? Can they be concurrent or not? Fortunately, very often we have regulations that tell us what is the concurrency factor between extreme loads. So what is the probability of these loads be concurrent? And this regulation also gives these suggestions in consideration of the outcome from a failure of the structure. So if the failure of a mooring point is something manageable, not causing any big damage, of course you can decrease its size. You can be less conservative. If the failure is generating a disaster, you have to be conservative. So the guidelines or regulations or laws in force generally help you in making this selection, but it's extremely important that you are clear what is the big picture, what is the requirement. So here there is a definition. Normal loads refer to any load that may be reasonably be expected. Extreme loads may occur in exceptional situations. They are infrequent and unlikely to occur at the same time, unless there is dependence. This is something that I forgot to say. So what does it mean, dependence between extreme loads? Think of extreme wind and extreme waves. They are dependent. If you have extreme wind, then you're likely to get extreme waves, because waves are generated by wind. What does this mean? It means that it's not unlikely that extreme wind occurs at the same time as extreme waves. This is quite likely. So we have to be careful. If there is complete independence, like the example that I made of the extreme wind plus track accident, okay, one may say, if I have an extreme wind, it's more likely to get a track accident. On the other hand, we understand that, the dependency is very low, very reduced. And therefore, in this case, you may be allowed not to consider the concurrency of the two extreme loads. Okay, so how to estimate loads? Refer to standards, guidelines, and formal regulations. This is what I said. Formal regulation can be issued by national and international authorities. Keep this in mind, because I talked about national authorities earlier, but there might be also international authorities. First, get information on standards, guidelines, and regulations, and be aware that you have to consider uncertainty. And how to account for uncertainty? There is a traditional way in engineering to account for uncertainty is through safety factors. So when you are uncertain, you introduce a safety factor. There is a classical value for the safety factor, which is 1.5, which means that you oversize your infrastructure 50%. It's not always 1.5. Usually, this is the classical recommendation. The safety factor, of course, should be proportional to the level of uncertainty that you are expecting. And also the safety factor very often is regulated by guidelines, by standards. Like, for instance, the extreme wave, there might be a regulation that says increase 20% extreme wave height, estimated extreme wave height. And be careful of randomness of the nodes, which implies the presence of uncertainty. Remember, uncertainty means limited predictability. Limited predictability is what we are concerned with. And uncertainty also means randomness. When you have randomness, you have uncertainty. When you have uncertainty, you have limited. So what is randomness? Randomness, if you think at the wind forcing, at the wave forcing, it's clear that it's random. In fact, probably you already know that to estimate the wave height, the expected wave height for a given record period, you can use a probability distribution. Did you study already the Gandhi distribution with Professor Chieti? Perfect. And so a probability distribution, which is the typical tool that you use to deal with randomness, to deal with uncertainty. So beware of the random effect, which means that when you estimate wave height, there is randomness. And once again, randomness means uncertainty. You cannot avoid it. When you have randomness, when you use a statistical approach to estimate a load, it means that there is randomness, otherwise you wouldn't use a statistical approach. And randomness means uncertainty. And therefore, uncertainty means a safety factor. Okay, and yeah, beware of the responsibility of the engineer and the ethical codes. I think I already discussed this. As an engineer, you are responsible. So you are different from, for instance, a researcher, a scientist who is not responsible for their conclusion. As an engineer, you bear a responsibility. What does it mean, the responsibility? It means that if something fails, the engineer, like a medical doctor, is called to provide a justification of what happened, provide a justification to waive their responsibility. And this justification, of course, has to be provided based on technical arguments. And therefore, beware of that. I very often repeat to students that, I mean, to defend what you have done, the best way is to rely on data and standards, regulations, and the most recent technical developments. And beware also of the ethical codes, because the ethical codes precisely suggest you how to take into account of the risks that are associated to your profession. And ethical codes are issued by, for instance, scientific association. In some of the cases, like the University of Bologna has an ethical code or code of conduct. They can be issued by authorities, can be issued by municipalities, by universities. So I learned in my experience to pay attention to the ethical codes because, you know, sometimes one thing, okay, this is not really technical, who cares over the ethics? And the ethics, some people erroneously see it as, I don't know how to say in English, but like suggestions on how to behave. Okay, so some people think, okay, ethics means how I should behave, how I should dress, or it's not only that. And actually, I would say it's not that. Ethical codes suggest to you how to carry out your profession, and not giving technical terms, but giving recommendation on managing uncertainty, managing communication, managing any trouble that you may get in your profession. So I must say, I was not interested at all But then I learned, based on my experience, to be aware of the ethical codes. For instance, when the University of Bologna issued the new ethical code, I think it was in 2024, I took the time to read it because it was suggesting how I'm expected to behave with students. And it's extremely important to be aware of these recommendations because they are something that if you don't respect, you can be liable for that. So pay attention to the ethical codes because it is something that generally for an engineer, they are not very interesting, but actually my suggestion is if you behave in an ethically correct manner, and I'm thinking that this terminology with a positive interpretation, because sometimes, people say, you are too ethically correct, which means that people look at the form, but don't look at the substance. So I am focusing on the positive interpretation. The positive interpretation is that if you are ethically correct, so if you behave in a manner that adheres to standards, this gives to you a reward also in your profession. In the long time, and sometimes also in the short time, brings to you, it helps you to increase your reputation, to increase your credibility, which is extremely important for an engineer and for a professional in general. But for an engineer, it's extremely important that people have trust of you, that your reputation is good. Because sometimes we are involved in the design of intervention structures that are impacting on the environment, and they may divide people and in their opinion. And therefore, if we have a good reputation, people trust us, this helps a lot in getting to target, which is a good thing for both ourselves, because we finish our job, and for our mission of providing a societally relevant contribution. Okay, so let's go back to the load estimation. And here there is a quote which I think it is interesting, so I copied it here. Keep in mind this reference here is an openly available contribution. I show you where you can find it. Okay, so just 1 second. It should be in the list of references. Yeah. So port designer handbook. So if you search for this, just 1 second, you should find a free PDF. Let me check. Okay, this is not free. Because the last editions are, you see, the last edition are very recent. They are not free, but I think there is an edition that is free. Bit slow, so just 1 second, PDF. Okay, this one can be downloaded. This one can be downloaded, and I think it is the 2010 edition, I would say. Don't see any date here. Anyway, this is interesting. It is interesting because it's publicly available. And it is interesting because there are many recommendations and guidelines for the port designers, and some of them we will discuss explicitly. But we are not discussing anything because, I mean, port design is a very large problem, very large, let's say, very comprehensive problem. Because once you estimated the load, you have to decide mooring points and the berth structure, the foundation of the berth, and also you have to design the roads connecting the land to the berth. You have to design also the buildings of the berth. and you have the design also of the positioning of the cranes, of everything. So, of course, we don't discuss all this. Basically, we focus on load estimation and then stop here. And if you want to get more recommendation, this is a useful reference. Another useful reference is what you see here, the Spanish standard. And this is an interesting reference because it is standard for Spain. It's no more available. So let me check. I have to fix this link. I'll fix it. Okay, or let me see if maybe that we can find it on the web soon. Let me just check because I'm curious. It is here. Okay, it's here. And it is in Spanish, but it is quite well understandable. And this is a very useful guideline. Useful also because it's free. So this is why I referenced it here. And another useful reference are, as for many other engineering projects, the Eurocodes. So let me just check. Eurocodes here. Let's see if the link is still working. Yeah, here are the Eurocodes. So it's ISO norms and standards, and usually they are divided by categories in depending on the type of design that you have to make. Okay, and some of them are free, other not. As you see here, action on structures. I would say that. I would say fields of application. I would say that most of them should be free. Action of structure, design of concrete, geotechnical design, design assessment and the retrofitting of structures for earthquake resistance, etc. And these are another useful reference. Okay, now let me just go back here. Good. So, reading from Torresen, different countries have different regulations. Yeah, as we said, all constructions have to be in accordance with the legislation in the country in which it's built, of course. Many countries have their own standards for marine and coastal construction, but some do not. The designer has to find out whether or not there are national standards or guidelines that have to be used for design. If such national standards exist, they have to be used. And if national guidelines exist, it is recommended to use them. If no national legislation, standard, or guideline exists, the designer is not required to use specific design manuals, but it is highly recommended to use internationally accepted standards and guidelines instead of trying to create a specific guideline for the project. So I fully agree with this statement. And here you see that I put the emphasis on Eurocodes, which can give orders of magnitude for safety concurrency factor and individual loads. Okay, of course. So, loads. Here is a sketch that I remade basing on what I could find on a textbook. Of course, to make the sketch available to the full world, I cannot take figures from textbooks, so I remade it. So this is the first classification, corresponds to the first classification of loads that I introduced from seaside, from berth, from land side. And you see the examples here. So from seaside, waves, ice, pressure, ice pressure is rarely considered because only few seas are subjected to get iced during the cold season. But in some of the cases, of course, it may happen. And in this case, you have to consider ice pressure. And of course, the danger is higher if you have a low salinity. So if you have a sea front with very low salinity, for instance, because you are close to an estuary, it has to be properly considered. Ice pressure is extremely important when there is ice. You know that if you put a full bottle of water into the freezer, the water breaks, and there is no way it doesn't happen. And I mean, the pressure of the ice breaks the mountains. So it is really very, very important. Waves, of course, are another forcing, and these are horizontal loads. Okay, and then horizontal loads from docking ship, ship impact, and friction. Bollard forces. Bollard forces are bollards are the mooring points. Just 1 second. Bollard. You see, these are the bollards and bollard Harbour. These are the bollards. Okay. Okay, fine. And the bollard forces are essentially horizontal forces, but they are also included in the vertical loads. You see that beneath the horizontal loads, we have the vertical loads from the seaside. There is a component of the bollard force in the vertical load. Why? Because the ship is higher than the bollard. And therefore, typically, the mooring line, which is the rope connecting the bollard point with, I don't remember the name of the anchoring point over the ship. There is a name which I will remember later on. Just a second, I have an amnesia. So the mooring line, the rope connecting the ship to the bollard point, is not horizontal. Okay, in some of the cases it can be almost horizontal if the ship is a flat ship, but in most of the cases is inclined at an angle, and therefore there is a vertical component. But the horizontal component is generally larger. Ship impact and friction. Friction, it's through the fenders. What are the fenders? 1 second, fender. The fenders are, no, fender are the pillows between, these are the fenders. This is the nicer picture, okay? This is a usual fender. Sorry, okay. This is the usual fender. And it is like a pillow between the structure and the ship, because otherwise, of course, if one brings the ship against the wall, it's not a good thing. And the fender is conveying the friction forces from the ship to the berth. Okay. These are the impacts from docking ship. From ship already docked, there are bollard forces for the action of wind, waves, and currents. And the vertical loads, you see bollard forces, vertical forces on fenders, and ice forces. Perfect. These are the loads from the sea. By the way, this sketch here is related to a berth that is open. It is called open berth. It is basically sustained by piles. Another possibility is the closed berth, which I mentioned earlier, where we fill the space between the extremity of the berth seaside and the land with soil. The open berth typically is a solution that is used for small berths. In some of the cases, the berth may also be a floating one for small ports, can be a floating berth. It's possible. Now, loads from the berth, we have horizontal loads, thermic dilatation, cranes, wind force, because of course over the berth you may have buildings, and the buildings are subjected to wind forcing. Wind forcing close to the sea is of course important. We will see how to estimate wind forcing, and you will see that indeed they are important forces. There are forces against curves. I'll show you in a moment what curves are, and friction forces. Vertical loads, buildings, the self-weight of the berth, superimposed load, like traffic, snow load, this is possible and it's important in some cases, and ice forces. Of course, the cranes can also cause a vertical load, but actually the self-weight of the crane and also the weight of the transported material is not really a huge one. It is more important the horizontal load caused by the crane when moving these materials. And this is why in the vertical loads, the cranes are not explicitly considered. They are included in the superimposed loads. In the horizontal loads, they are explicitly considered because it is a superimposed load that can cause an important horizontal forcing. So what are the curves? I think we can just, you see, it is related to braking and images. These are, for instance, curves to protect the sidewalk. And if we look at the curve for a port, curve girls, don't see any useful, but you can see what I mean. Over a berth, these curves are meant to avoid that an approaching car gets into the sea. So they are limitators of the running of moving object. They are meant to stop moving object over the berth before they fall into the sea. And this is why they can bring an horizontal load. Still, I don't see a very useful picture, but we will find a way to carb wharf. We will find a way to find a picture, but I think you understood. A wharf with the H or carb here. Anyway, I think you understood what I mean. Okay, let's go back here. And loads from the land. Horizontal load, soil filling, load on filling, and of course, load on filling could be included in the superimposed load, but actually the load on filling can be also can occur over the land, and then it originates a pressure over the filling of the berth. So it is also mentioned here. Pour water load, because indeed the water getting into the soil gives a pressure, a relevant pressure. Vertical loads are soil filling and superimposed load. So this is a brief schematic of it. We will not discuss on all of these loads, how to estimate them. we will focus on the estimation of wave load, wind load, and current load. These are our focuses. And I'm neglecting here the discussion on the soil filling, the loads from soil filling, which may be that are discussed by my colleagues for your case working on geotechnics. And I will not discuss also the loads from forces against cars, the loads from impact of ship. I just would like to remind you, as I said last week, that most of Harbour engineering and coastal engineering is empirical. So in some of the cases, these loads can be estimated by applying the laws of physics. In other cases, like the loads on the carbs, the loads due to ship impact, of course, one could estimate by applying the law of physics the transformation of kinetic energy of a ship that goes against the berths into pressure. But actually, what we often use are empirical formulations, which depend on the size of the ship, the tonnage, so the weight of the ship, depending also on the traffic condition, the expected traffic. We will not discuss explicitly these loads. Now, let me say something more. I already anticipated some consideration on the combination of load, but let me say something more on that. So, what is the ideal approach to find the most critical combination of factors? So here are brief guidelines. The number of different loads is relatively high, as you have seen in this figure here. But our experience suggests that live loads, so the exceptional loads, do not occur at the same time. In general, it is unlikely. This is a rule of thumb. So I think you understand what I mean with the rule of thumb. It means a very basic and empirical suggestion. Basic means that you don't have to follow it like a rigorous suggestion, but has a very rough guideline. So what is our rule of thumb? It is unlikely that more than two different live or accidental loads occur together unless they are dependent each other. So we already clarified what is dependency. This rule of thumb basically says that once you consider two contemporaneous accidental loads, it is considered to be okay in ethical terms, in best practices terms. You may consider three if you believe that the consequences of a failure would be extremely important. You don't have to consider the accidental loads, the tens of accidental loads occurring together. So the seismic load is considered normally an accidental load when designing berths, but look at the local regulation, because you know that also in Italy, depending on the region, depending on the location, there are classification of zones according to the seismic hazard, and you have to follow them. So just get what I'm saying here, keep always in mind, needs to be checked on the national regulation, international standards, etc., etc., etc. Okay. One important thing is the design life, and because also load estimation depends on the design life. What is the design life? It is the expected duration of the infrastructure or structure that you are designing. Of course, if the expected duration is very short, like the structures that are used during the construction works, they stay there for the duration construction. So they may stay there for a couple of years if the structure is very important. The safety factor against the extreme loads don't need to be as large during construction works as in the long term. Because of course, if you think of an event with a low probability, like an earthquake of extreme intensity, it's an event with low probability, which means that every year you have a low probability to get hit. But if you go into the future for 1,000 years, the probability of getting in 1,000 year an extreme earthquake is larger than the probability of getting an extreme earthquake in 1 year. And therefore, if the expected duration of your infrastructure is 100 years, 200 years, 500, then the safety factor may be larger, needs to be larger for extreme loads. And also the concurrency factors. So anything related, and also load estimation. Load estimation is dependent on the design life. So the design life is an important factor. I'm sure that you already heard about design life project in your experience, and how to determine it. The design life usually is suggested by regulations, by national standards. So, for instance, we have a national standard that suggests that when you build a bridge over a river, the return period of, let's say, design life, talking about return period later, design life should be at least 100 years, because you have cars traveling over it, and therefore you want to be safe. Of course, increasing the design life, as I said, means that you get safer. You have to increase your safety factor. I will give you some orders of magnitude here. General design rule is that ordinary berth structures in commercial ports should have a design life of 50 years or more. But if you have berths serving special industries, container traffic, oil traffic, you may take a lower design life. Why? Because it is predicted that you will need to renew these structures after a short time, because these dynamics of industrial activities are rapidly evolving. So basically they say, okay, this berth is going to be substituted in 30 years. And therefore, you are allowed to adopt a design life that is shorter. And it's not only a matter of safety factor, it's also a matter of the materials that you use. The materials that you use, you can use cheaper material if you think that the design life is just 30 years. Flood protection works and also bridges, which are related to floods, design life for more than 100 years. Why? Because, it is, we know that floods may cause a huge impact. And therefore, also in terms of human lives. In general, keep in mind that given that the design life is related to safety factors means safety, when you suspect that I said the consequences of a failure may be relevant, like loss of human lives, then you have to increase the design life, because in this way you increase the safety factor. And therefore, floods, our experience is that they are really threatening humans, and this is why we suggest more than 100 years. But there is an exception. For urban flooding, which is not our concern here, but urban flooding, it's not expected to produce a big impact unless in very particular situations. Urban flooding usually means like 30 centimeters of water. Urban flooding is due, with the urban flooding, the flooding that is originated by the insufficiency of the failure of the sewer system. You don't get meters of water. You get like 20 centimeters of water. So usually there is no real danger for the human life. So sewer systems in urban environment are designed with a return period from 2 to 10 years. So there is no need to make big sewers, because the risk is not so relevant. Okay. Now, also an important consideration: birth structures and birth equipment are highly exposed to corrosion, and corrosion means that they don't last a long time, and therefore you may need to recover it frequently. This means that the design life can be lower. A general rule suggests that design life should be adopted by considering the impact of a failure. This is what I just said. Okay. So I think I have some orders of magnitude here, some rules of thumb again, and indication of design life that may be adopted as a first estimate for a given type of structure. Breakwater, 100 years. Reinforced open berth structures, 50, 100 years. Steel sheet pile berth structure, 50 years. Rubber fenders, you already know what fenders are, 10 years. Concrete aprons and roads, 20 years. These are indications. But once again, you have to look at the regulations. Okay. Now, two main categories of berths. The wharf is aligned with the coastline, and the pier protruding into the sea. Other two main categories already mentioned by me: solid structure berth, open structure berth. Of course, depending on the berth structure that you select, the forcing changes and the load estimation changes clearly. Solid structure berth can be divided into two main subcategories. First of all, let me say solid structure usually is associated to more importance and to larger structures and to a higher traffic, which means very frequently safety factors that are more relevant. So how can they be realized, solid structure berths, in terms of this type of structure? It can be a gravity wall structure, which means that the front wall, front means towards the sea, of the structure with its own dead weight and bottom friction is sufficient to resist the loadings. Okay. Sheet pile structure. First of all, I think you know what is sheet pile, but let me just show you a couple of figures. Sheet piles. These are the sheet piles. They are more a thinner structure with respect to gravity walls. And you see how they can resist here. No, this one can be closed. Check. Okay, no, okay. You see, okay, it's not very clear. You see how they can resist the pressure of water. Of course, they can also resist with the self-weight of the filling material, but usually they are reinforced with an internal structure. So the sheet pile structure, the front wall is made by sheet piles in steel or concrete. We saw in the figures they were steel sheet structures, steel elements, but it can be also made by concrete, which are fixed to an anchoring plate or another structure like a wall behind the berth. The open berth structure usually stands over piles set offshore from the natural extent of the land. And this type of berth is more flexible. It's more adopted when the port is not very important, and more space for docking. But, you know, clearly the amount of load that can be sustained by the berth is lower. Okay. So depending on the expected traffic, depending on the geomorphology of the land, depending on the purpose of the berth, of course, you select the solution that is most convenient and less impacting. Of course, the open berth is less impacting with respect to the solid structure. This is an example of an open berth, and you see that this is could be also floating. We cannot understand here if it is floating or fixed over piles, but in some of the cases can be floating. And if you think of the berth in Venice along the canals, some of them are floating, and the structure has very flexible and open berths. Okay, just let me check over the web page. Okay, here there is a sheet pile structure in Germany. You see, this looks like steel sheet piles. And these are elements that are joined together and can offer a high resistance. If you see the vertical load, the crane over the berth is indeed very relevant. Let me see if there is some other figure. No, okay, perfect. How do we decide the most appropriate berth structure? We have to consider these indications here. And in particular, we have to consider soil conditions. Underwater work, is it needed? Is it not needed? Can we sustain the underwater work? Because, of course, it is very expensive. Wave action, equipment. Equipment means what you have to host over the berth. If you have big cranes, also the open berths may be not the best solution. Material, time to construction, future extension. Future extension means the ability for us to extend the surface of the berth. And also we have to consider the cost. And these drivers are evaluated through a different kind of investigation, socioeconomic investigation, prediction of the traffic, and of course, cost estimation, etc. And also investigation of the geomorphological asset of the land, of the harbor, where we have to make our intervention. Okay, what are the dimensions of the berth? Orders of magnitude. It's important to get a big picture of what is the size of the structure that we want to design. As a rule of thumb, you can consider these sizes. The length of the berth is varying from 5-10 meters for a small boat, one small boat, to over 400 meters for large ships. And the longest ships reach an extension of 400 meters or more. The length of the berth should be roughly 10% longer than the longest vessel to be moored at the berth itself. Because if you have a berth that is 400 meters long, you cannot host a ship that is 400 meters long. The width of the small docks should be at least 2 meters for a ship length up to 10 meters. And the length of the pier or wharf up to 100 meters. Even more, you can extend the pier even for a long distance. The width should be increased to a minimum of 2.5 meters for ship length between 10 and 20 meters, and 20 meters for and dock length between 100 and 150. The width should be minimum 3 meters for ship and width length exceeding the above limits. Okay, so at least 2 meters, but then it can become more. Okay, I would make the break now. Do you have any question? So far, no. Okay, let me check if somebody's online. It looks like no. Perfect. Now let's shut up the micro and the webcam.
Invece ho chiesto a
Okay, let me restart. So some additional indications. When we have the opportunity to do that, it's advisable that the berth is aligned with the direction of the dominant wind and the dominant current, because it makes approaching the berth by the ships easier. And you can understand why, because usually the ship approaches the berth by running in a parallel direction, in the same direction as the berth. And if it is the same direction of the wind and current, it's easier, the approach is easier. Usually it is the transversal wind, transversal with respect to the berth direction, and the transversal current that make berthing more complicated. In terms of structural loads, some orders of magnitude. We suggest to design the berth against a live vertical load of at least 4 kilonewton per square meter. Higher loads may result from detailed analysis, of course, because this is a vertical load, depends on what is above the berth. And in terms of vertical positioning of the berth floor, meaning the vertical difference between the floor of the berth and the mean sea level, it is recommended to make a specific assessment which should take into account tide dynamics, of course, type of ship, and the other conditions that may suggest a refined analysis. A difference of at least 1 meter is recommended. And of course, tide dynamics is very relevant here. And the tide dynamics, especially in the ocean, is important. I mean, there might be a tidal excursion that is several meters. So, of course, we have to take it into account. For small floating berths, the problem is, of course, easier. This is why sometimes we adopt floating berths, because their positioning is flexible. And we can get flexibility in the vertical positioning of the berths. Okay. And a few words about the environmental impact. The environmental impact of ports is extremely relevant, and it is relevant both in terms of contamination of water and the contamination of muds, which are in turn transported by the currents. It is also relevant environmental impact for the associated impacts given by the traffic, given by the noise, and given by the load over the road infrastructure, indeed, it is something that needs to be carefully evaluated. This is why sometimes we get oppositions from the population, from the stakeholders, when important projects are planned. Evaluation of the environmental impact is not easy. It depends on the type of concern that we have. And there are some guidelines that we can use. The number of these guidelines has been increasing recently for the concern, the increasing concerns on the sustainability of these activities. And these guidelines may be useful to identify what is the most relevant, what are the most relevant impacts, so to determine priorities. And some of the guidelines also suggest what type of assessment we should carry out. As a very broad indication, I may suggest you to keep in mind the Sustainable Development Goals by the United Nations, which I think you know quite well. And some of them are directly related to the sea environment and the marine environment and port activities. So if you look at the description of these goals and the associated guidelines that are provided by the United Nations, you get an idea of what are the most relevant impacts. And again, you have to refer to the national guideline. Here, I'm not going into the details. Maybe that we have time later on to look at in more detail about to talk with more details on the recovery of contaminated muds. This is really a matter of big concern because the ports must be periodically dredged. I think I already mentioned last week about this. The ports the harbors needs to be periodically dredged because they are subjected to sedimentation, because they are sheltered areas. And I mean, they get sediments from the sea. Sheltered area means that the velocity of the water is the energy associated with the water movement is lower, and therefore we have sedimentation. We have deposition of muds, and these muds are contaminated. Contaminated because, you know, the loading activities, the engine of the ships, they imply a release of contaminants and a release of oil in some cases. And therefore, when you dredge this is material that has to be treated. And so treatment of this material is indeed a big. And maybe that we will have time to discuss because I have a lecture devoted to this. I think it is important because even if it is something that it's not managed by an engineer directly, so it's more a matter of logistics, I would say. But on the other hand, it is a concern that is really prominent nowadays. For instance, here the Port Authority of Ravenna mentioned to us once that they indeed have relevant problems with the contaminated muds, and they really are looking for expertise to suggest innovative solutions about that. And also, if you look on the web, you see a lot of references. So maybe that we find the time, because I think it's important to be informed. For now, I just want to discuss with you this brief classification of these categories, this classification of environmental impact, which may be given by the port activity, may be given by the impact on the sea caused by human-induced pollution, emissions from transport networks. This is really also important, and land use change, and in particular urban expansion, because when you build a port, then it implies a support to urban expansion, which is good on the one hand. On the other hand, of course, it's a reason of concern. You may be aware of the Blue Growth maritime policy, which was recently promoted by the European Union. It's a long-term strategy to support sustainable growth in the marine and maritime sectors as a whole. And so you can look at the website to get some information. Why am I suggesting this? Because, I mean, the discourse on sustainability and environmental impact is something that is not directly related to engineering, and usually environmental impact assessment is carried out by other professionals like ecologists, like experts in vegetal and animal life, expert on the fish side, expert in ecology, again, biology. So it is something that is, as I said, not directly related to engineers. And we engineers sometimes have the habit of considering this issue something that is not really important, because we tend to give more weight to the need, indeed, to support our development with infrastructures. Infrastructures are, of course, needed. And sometimes, also in view of the fact that this evaluation of environmental impact very often are not very technical, they require quite a narrative assessment of the implications of what we design. So sometimes we tend to, in a way, give low priority to them. I think this is justified. It is also my habit, even if I'm very much motivated to support sustainability, it's also my habit to consider that evaluation of the environmental impact is not something for me. On the other hand, I realize that it's extremely important to stay informed, because given that communication is an important part of our activity, it's an important part because, as I mentioned, the regulations impose to be transparent on our decisions, on our design. So communication with the stakeholders is indeed important, and communication must be supported by information, multidisciplinary information, also in disciplines that are maybe more related to environmental impact assessment with respect to engineering. And but we as engineers also to have the skill required to talk with these people, with these colleagues, need some information. So I really realized that I needed to study something related to these policies, even if in some cases I think they are a bit overambitious, because in order to ensure that we have a sustainable development, we have to make sure that we have sustainability indeed, but we have also to make sure that there is development. And of course, if you insist too much on sustainability, then you undermine development. On the other hand, it is also true that if you insist too much on development, you undermine sustainability. So I think, anyway, the information is important, and this is why I wanted to mention to you these European policies, which probably will be revisited a little bit, because I think we have been a little bit too optimistic on our capability of promoting a green development. It's important that the development is sustainable, that's for sure, but probably we have been a bit overly optimistic. And you know that, especially today, there is an interesting confrontation between the recent development and the recent orientations of the European Union, United States, China, also in terms of sustainability. So it is indeed an interesting confrontation, and for that, I think we need to also to take care of our education in these subjects. And related to this, there is the problem of energy. It's not a problem, the interesting opportunity of energy from the sea. I think Professor Archetti is talking about this, so I'm not insisting. And indeed, we are trying today to exploit the renewable that can come from the energy of the sea environment, energy that may be given by wind, may be given by wave motion. It is indeed something interesting. Here you see an energy generator that uses the energy of waves. And the potential is huge. On the other hand, like many renewables, this is not stable. It's not a stable source. It's not a flexible source. We need to produce energy when it's available. And keep in mind that energy cannot be stored. Electricity cannot be stored. So when you generate electricity, you have to use it. And this is indeed something that, I mean, interesting, but on the other hand, must be coupled with other forms of energy production to make sure that there is compensation. Compensations when the renewables fail because there is no wave motion, there is no wind, or in any case, they are not in the top range of production. But it is indeed an interesting topic, and also interesting from the engineering point of view, much interesting. Okay, contaminated muds, I think we can skip this because I already mentioned it. You can see here the figure of two dredging machines. Indeed, as I told you, if you look at a port, an important port like the port of Ravenna, you continuously see dredging machines traveling around and collecting muds. And they don't know where to displace it because you need space and you need also to treat these muds, which is, I mean, interesting. Okay, now, I would like, as I anticipated, first of all, to give you an important update, which I forgot. Next Wednesday, I cannot teach. I will change my calendar on the website. So please take a note. I will put a note also on Virtuale and on the chat of Teams. So it means that the last lecture will be 1 week later. I think our last lecture was, let me go back here. I think our last lecture was April 9, it will be April 16. Okay, I'm sorry for that, but unfortunately I have to attend a conference. I try to skip it because it's also a little bit boring, but I couldn't succeed. And therefore, we will see each other again on March 12. Okay, and once again, I will change this, or if you give me 1 minute, I'm changing now. Just 1 second. Okay, so I prefer to make the change now because otherwise here we are. Okay, very good. So March 5, we remove it, and then we make here April 16, 4 hours. Okay, it will not be changed online. Online, I mean the official timetable of the university, because it takes a little bit of time to make the change. Okay, and now, as I anticipated last week, I would like to start discussing with you to make an introduction to coding. We have about 1 hour to do that. So last week, I mentioned to you a software which I would like to start with, and it is this one. Can I ask you to make a brief poll? You had already some experience in MATLAB coding, correct? So MATLAB, everybody? Okay, good. R coding? You, okay. And the other 3 not, okay. Python? Yes, you. And the other Python, you don't have any experience. Okay, good. Good. Yeah, good. It's no problem. This was my assumption. Okay, so for you, maybe that the introduction may be a little bit useless, and feel free if you prefer to leave the lecture, it's no problem at all. So in order to install it, first, let me check if I have it on this PC. I would say no. 1 second. I don't think it's here. Let me check. Okay, let me download it. It is also good that we can install it together. Okay, download, you have to click under download, CRAN. You can take any mirror that you want, it's no problem. And then you click on a mirror, and then you get Windows, in this case for me, because this is a Windows PC. If you have a Mac, you have to click on Mac. So Windows, you have to download the base. And then here it is. And then once you download the installer, you can just double click it, which is okay. Let's see. Okay, so let's install in English. Next, just take all the defaults. I took all the defaults. I just changed one because I didn't want the icon on the desktop. It is quite quick installing. Finish. Okay, here we are. Let me check if I can. Let me see, where is it? Okay, here it is. Okay, this is our. I don't understand why the initial page is still in Italian. I don't know why. And anyway, no problem. And this is R, which is software working through a console like MATLAB. So I think there is not much to say about working over the console. It means that we have to give instructions by writing. It's not like any Windows application where we have the opportunity of working with the mouse and working with the menus. Actually, here there is a menu because this is the Windows version, but the menu is not really allowing us to work. It is just an aid that you have in order to save the data, to print it, to make to a cut and paste, etc. And it's not very helpful. Also the icons, save, but it is impossible to work with the software without working on the console. So this is then a possibility that we have to make computations in engineering. So you may ask me, why R instead of, let's say, MATLAB? The main reason is that R is becoming a standard. It's very, very diffused. And there is the opportunity to find a lot of programs that are already prepared for engineering. So it's widely diffused. And the reason why it is widely diffused is that the capability of the computing capabilities of this software are really excellent, comparable to MATLAB. Of course, you may find some MATLAB applications which are not readily available for R, as well as you may find the opposite, some R applications that are not as easy in MATLAB. But the main difference between the two, actually, it's not in the capabilities, it's in the fact that R is free, so it can be openly downloaded, it's supported by an open community, it's non-commercial. So this means that the community is large. This means that you can benefit from free support. a lot of things. So I firmly believe, because I say that also engineering is rapidly taking place, taking room, taking attention. I believe it is definitely useful to try to integrate our knowledge of MATLAB with the knowledge of an analogous but free open software. There are other opportunities actually, not only R. R is probably in terms of free software for mathematical computation is probably the most diffused. There are other opportunities. I think R is definitely worth learning, also because it's really not so difficult once that you know MATLAB. There is another option, which is free, open, very widely diffused to make mathematical computations. And it's Python. Let's forget about it for now. But I also would like, in this course, to give you some basic information about Python. Because, you know, all of this software have peculiar behaviors. And it's very important for you to know different tools for carrying out, for completing a task. Because once that you know several alternative solutions, you can select the most efficient one. And efficiency is extremely important for an engineer because, you know, it looks like it's not so relevant, but if you gain the skill for completing a task in less time with respect to your competitors, of course, your reputation, your value, and your opportunities increase correspondingly. And it's don't see competition as something like who wins survives and doesn't win die. It's not like that. Competition is just the fact that if you have more skills, you can get the more interesting works and discard those works that are less rewarding in terms of also not only economic reward, but also personal reward. So it is extremely important to try to be efficient. And there is a saying in Italy which says that you cannot do something well and quickly. I think that instead it is possible. It is possible to do something, to perform a task well and quickly, excellently and quickly. But you have to get the skills for doing that. And the skills are knowing different methods, different tools. So this is why I am motivated to give you the basis for learning these additional tools. Of course, I give you only the basis because we cannot become an very experts. I have to say that I am not as well. I cannot say that I am a full expert of Excel, even if I have been working 30 years over Excel, but I'm not an expert because becoming an expert means also that you become very specific. We don't need to get into specificity. We need to get a broad view. So this package, let's concentrate on R for now. It's console-based, which means that you have to type with the keyboard the instructions, which means, in turn implies, that you have to know these instructions. Fortunately, the programming languages are very similar, but still we need to know the instructions. And this is what we are trying now to get the knowledge that helps us to learn the instructions that we need. So let's start from the basis quickly, and then we move forward quickly. So if I write 2 plus 2 in the, let me just increase the font 1 second. If I type 2 plus 2, I get the result. And let me now clear the screen. And I clear the screen with Control plus L, same time. So once again, 2 plus 2, 4. A first important hint, if I use arrow up allows me to get the previous very large number of instructions. And arrow down allows me to instead move forward. So I have now one instruction only. Let me just assign a variable now, a equal 1. And if I go back with arrow up, I get the previous instruction and the previous one. So arrow up allows you to recover quickly from the previous instructions. Another thing that you can do to see the previous instruction is to type history. And then you have to put around parentheses empty. And you see, this is the history of what I did today. Twice 2 plus 2, and then a equal 1 history. Why the double parentheses? Because history, look at these three instructions. 2 plus 1, 2 plus 2 is a mathematical operation. A equal 1 is a variable assignment, is a step forward. Is a step forward with respect to 2 plus 2. History is a function. So it is an instruction that performs a series of operations, not just one. So when I type history, what they does is to get all the previous instructions, putting them on the screen, and then waiting for your next input, which is quit, Q. For some reason, I don't have in this screen the full screen, but anyway, it's not really a problem. I think the reason is that, okay. No, that's fine. Okay, so
2 plus 2 down right again.
Arrow up. In the small keyboard of the PC, you should have arrow up. Did you find it? See, because you make PCs. This one. But no, this no. Okay, now, as I said, history is a function, and the function is something that is programmed into R. And as I said, the difference is that an instruction is just one task, but the function is a sequence of tasks. And typically the function depends on arguments that have to be put into the parentheses. So for instance, there is a function that performs linear regression. And then as an argument, it takes the data on which we want to perform the linear regression. Therefore, the function must have arguments because not necessarily, like history doesn't have any, but still it's a function. And therefore, by default, R assumes that any function depends on arguments. They may be void, null, but it is assumed to depend on arguments to give you the opportunity to give these arguments. And then I want to give you an example. Let's try to program a function. Now, I am making quite a jump step forward. So I try to follow me, and then we discuss what I did, okay? So because I am moving a significant step forward, because now I am already passing to programming. So build a function, we will build a very simple one. Build a function means programming. Also, let me say one thing. The way I am teaching now this platform is unconventional, it's typical of a speaker. It is learning by doing. So I'm not starting from the theory. I'm not starting from, okay, a language is made by, a language for coding is made by cycles, conditions, etc. I'm not starting from scratch. I am just doing, and we are learning by doing. So this means that it's very efficient because we jump straight normal paths. Because the next time, we already level the license. I will propose to you like estimate the extreme way high. And let's build a function that estimates extreme way heights depending on the record period, so probability of occurrence, etc. So it is very efficient because we go straight to the task. On the other hand, it's not complex. So when you start from the basis of the theory, you build one ring after one ring, and then when you get to the final result, you have a large basis. On the other hand, it takes we don't know time because in this subject, in this course, the purpose is not to become. On the other hand, I am pretty sure that once that you learn it by doing, you have all the means to expand your knowledge. So I give you the basis, and I am sure that in the future, should you need or should you wish to become more knowledgeable about art, I am sure that you have the basis. On the other hand, I need your cooperation. You need to interact. If there is something that you don't get, please let me know. Okay, let me write a function, and I want to write a function that takes the sum of two numbers. Okay, and the numbers are my arguments. So I want to make the choice of the numbers flexible. Okay, so let's see. My function equal. So I am assigning the name. I decided to call it my function equal function, and then I have to give the arguments A, B. These are the two arguments, two numbers which I want to sum. Okay, and then if I write return, you see that R is expecting for some more because R understood that you want to write a function. And then he's expecting for you to define the function. Okay? Now, given that the function is a series of instructions, I need to open the series and close the series. So I have to know in which way, what kind of instruction I give to R to mark the beginning of the list of the instructions and the end. And this instruction, this mark, is the curly bracket. Let me see in this keyboard how I can get it. So this is square bracket. Just 1 second. I need a different. And meanwhile, look for the curly bracket in your keyboard. This is strange because usually the curly bracket, I don't get it. Just 1 second. And then if I not succeed, I will tell you a workaround for getting the curly bracket, but I must succeed. Let me see. Okay, I found it finally. So could you find it in your keyboard? If I write enter, you see that it's still waiting because I marked at the beginning of the instruction. So what would be the way to find the curly bracket? First of all, one possibility is to press Alt GR, which is the Alt key that you find on the right of the space bar. Alt GR plus, you keep pressed Alt GR plus the number 6. This is a possibility. It didn't work with my keyboard. Now, you can write C equal A plus B. Simply, it is the sum. You define a third variable C, which is the sum. Return, and then you make return C. Return is another function, so you have to give it as argument C, and then the curly bracket again. And now it's finished because after the second curly bracket, the right curly bracket, R assumes that you have completed your function. Okay. Now you can write my function 2, 5, 7. You can also write, I go back with arrow up and I change this. B equal, so you assign the result to a variable. And then if you type B, you get 7. An interesting story. You can write my function A5. Remember that I defined A with the value 1, B6. So far we defined the two variables, A and B, and the function. If I want to see the variable, the list of the variables, it's here, ls, with the round parentheses empty. Good. Now, let's clear the screen. And let me make a small step forward. So let me go back to the definition of my function. I want to make a change. And in order to go back, I use arrow up. So okay. And now let me give default for the arguments A equal 10, B equal 5. And then I repeat the definition of the function. Curly bracket. C equal A plus B. Return C. And that's it. So it is like what I did before, with the difference that I give default values to the parameters. So what happens if now I write my function without arguments? You see that it uses defaults.
In case of repeat the text,
Sorry, it.
repeat the text. It function A equal then B apply.
Yeah, but I didn't go back with the arrow up. I just wrote my function with the round parentheses with the keyboard. So this instruction here was typed from the keyboard. Okay, good. Now, you understand that this is a very simple function, but you can really make a program, especially if you have to perform a task repeatedly. This is really a powerful tool because it gives to you the possibility to make these repetitions automatic. R has several functions already embedded. So before writing a function, we need to get some information on what is available. I give you an example. Log 10. This is the logarithm with base E. Another example, log 10, 1, logarithm with base 10. Or log exp 10, 10. Or sqrt 110. Sqrt is square root. So you may wonder, where can I get a list of functions? Two possibilities, at least two. The first suggestion that I give to you is to go to the website of R and look at the documentation, manuals. Here, there is a manual, an introduction to R, which is nice. And you don't need to look at it because it's not the only way of getting help. But it is useful if you want to get some more information. It is 100 pages, but don't be concerned. You don't need to read all of them. But this may be a quick reference. So number and vectors, simple manipulations, vector assignment, etc. Objects, matrices, arrays, data frame, reading data from files, which is indeed useful. So this is one possibility to get help. Second possibility, if you know, let me clear the screen. If you know the name of the function, you may get help very quickly by typing a question mark and then write the name of the function. So question mark, name of the function. And if I type enter, I get this screen, just 1 second. It's a bit slow, but it should appear. Let me just check it once again. I don't understand. Where is it? Just 1 second. Okay, here it is, because it was open in a browser. So here you have the help of the logarithm. And be careful. In the help here, you see that the arguments are listed. So logarithm expects between round parentheses has arguments. It expects the variable to be computed the logarithm and the base, but for the base there is a default, and therefore you don't need to write it. And the default is exponential 1, the number e. So you see that the help is important indeed. On the other hand, to call the help, you need the name of the function. So what if I don't know the name of the function? So there is a third opportunity. You go over Google. You go over Google and you search, just 1 second. You search logarithm R project. And then you click on the first link usually. 1 second. And here you get the link. You get the help. And there is, and you see here, you don't find the function log, but you see here, see also log. So we can go here, and you find the same help. So you go over Google, you write like linear regression R project, and you get the instructions to make the linear regression. Okay. Now, let's continue our learning by doing clear screen. Important question, how to save it? Okay, first you see here that there is an icon, save workspace. So let's try to click over it. I am clicking over the icon. Doesn't help much. Let's forget for it now. Okay, you see, this is the instruction. Save image. So save image. If you don't give any argument, what does it do? It saves your data, and data, I mean the variables, the function that I defined, in this position. So let me see if I have something there. So it's questo PC. Let me see my documents. You see here a directory R data created just now. No, it's just a file called, you see, just called R data with a point in front. This is where it saved the files. Look, this path, this route to the directory where data are saved is extremely important, because when you restart R, if you want to upload with this icon, OpenScript, if you want to upload this data, you have to know the location. So this location, this what is called path, so route to your data, is extremely important. So this is a way to know it, but usually it is under users, under your name, under documents, so your document directory. Can you follow me, or there is something where you're getting lost? When I tell you your document directory, your path, are you following me? Yes. Okay. Or there is some concern. Let me know if there are concerns, because I don't want to explain trivial things, but on the other hand, I don't want to skip some essential knowledge. Okay, so if you have any question, don't be shy. Okay, it's extremely important that you are not shy. Okay, good. So save image, but also you need another thing. You need save history. One thing, save image, I called it, I invoked it by clicking the icon. In general, my suggestion for you, don't use icon or menus, because it limits your vision. Okay, try to learn the commands by keyboard, by console, because if you stick on menus, menus are very limited. So, of course, you could stick on menus and then learn what is not included in the menus. But my suggestion is just forget about it. Also, in Mac, I'm not sure if you have the menus. So, save history. What does it mean, save history? It means that the history is saved. Okay. Now, let me quit R. And in order to quit, to go out, to exit from R, the instruction is Q, round parentheses. And then it asks me, would you like to save your workspace? Let me say no, because I already saved, okay? To make sure, just keep into account that if you quit and you answer yes here, automatically it saves both history and data. So when you go out, in order to in order to be double sure, you may write yes. Now I'm writing no, I'm selecting no, because I want to show you that I already saved, okay? But in order to double check, you could just select yes. And I say no, and then it went out. So let me now restart it again. So it's not here, just 1 second, it's here. Now it says, I already uploaded the previous workspace, so because, let me see, you see that the history is already here. Because I saved it, I saved the previous workspace and the history, and you see that the history is there. And let's see the variables. Yeah, everything is there. Let me just change again the font size. Okay, good. Perfect. Now, so now we know how to save. Look, saving and the history, it are extremely important because in R there is no, be careful, no undo. So if now I type, okay, I want to remove the variable a, rm removed a is no more there. And then if I say, oh gosh, I didn't want to remove it, there is no way to go back. Okay? And you may think that this is a big limitation. Actually, given that you have the history, it's not a big limitation because I can go back to my definition of A, which was somewhere here, and then I recreate it. It is just a change of mindset. You shouldn't rely on the undo. You should rely on saving. And you should rely on the fact that everything that you do is recorded. And if you save it, instead of undoing a mistake, you remake what you have done correctly. It's a change of mindset. It's not really something that you are losing. I tell you, I never regretted. I have been using R from 1993. 93, yes, 94. I never regretted to not to have the possibility to undo. Never. I only regretted one thing. There is some platform, I don't remember whether it's Windows, we can try, where Control plus Z, Control Zeta in Italian, Control Z, which is usually used in Windows to undo things. Control Z provokes R to go out without saving. Let me try if this is the case here. No, in this case, it asks me to save, but so I type Control Z again, and here I have, it asks me, would you like to save? But on another platform, which I think it is Linux, another platform, not Windows, Control Z is just out without asking. So this is the only thing I regretted, because sometimes it happens that you don't remember that you are working in R. You use Control Z instead of using another, because you want to undo, and you don't remember that there is no possibility to undo, so you type Control Z, and then it goes out. And this is something that I think should be fixed, but I never committed to write to the community and say, why don't we change it? Anyway, this is now a step forward because we learned how to save. Now, another step forward, vectors. Let me define a vector. So vector 1 equal, the vector is to be defined with a function, and the function is C, and the elements are between parentheses, 1, 3, 4, 7, 8. This is vector 1, and if you type vector 1, you get the vector. Important thing, completion of the instruction. So instead of writing vector 1, 7 letters, if I write vec, and then tab, you see vector, it completed the instruction, not really completed, because eventually it is in doubt between more than one option, how to define them, tab again twice, and you see it is telling me, would you like vector or vector 1? Vector is a function, and I say, okay, no, I want vector 1. Or sqrt, sqr, completion tab, sqrt, and it is only this one. So completion is extremely important because you can define a variable with even a long name like capital Q, capital letters, it's sensitive, and then equal, I'm not sure whether it takes the accents. Let me do like this, equal 10. Now, if I want to recall back this variable, let me clear the screen. I write capital Q and tab, okay, twice. And you see that these are the two options. And then I write QA tab. Perfect. Just think of it in this way. If you save 1 second in making an operation, like in this case, if I use the tab, I easily save 1 second. When you are busy with the PC, in one day, very easily, you may perform like 5,000 operations. It is very, very easily because you know how many operations we can perform in a minute. So if you save 1 second each time, at the end of the day, you save more than 1.5 hours, which gives to you what efficiency means. So when you are efficient, you have time to complete your job, double check, then go out for jogging or for whatever, for a drink, and then you get to the end of the day much more relaxed. If you are not efficient, you may not complete and you are not relaxed at all because you didn't have time to check, you didn't have time to relax. It makes a huge difference. Efficiency makes a huge difference in your working day. It's not just a matter of saying, I want to be the number one. This is not our concern. It's a matter of improving our lifestyle. It's clear everything in terms of completion. And now I want to remove this variable. So RM QA tab. So learn to use the tab, the arrow up, and learn to use the tab twice. Okay, now let me move another step forward, which is something really enlightening. So I have a vector, vector 1, and let me just see what are the values. Vector 1, sorry. Okay, let me define another vector, vector 2, equal, okay, let me see. I just type numbers by chance, 30, 10, 15, 33, and 25. Good. Very good. Now I have two vectors, same size. By the way, before I move forward, if I type vector 1, square bracket 1, I get the first element of the vector. And 5 gives to me the last element. Now, if I write vector 1 plus vector 2, it's interesting to see what happens. You see what happens. The elements are summed one by one. Good. Now, I said, important step forward. Let me clear the screen. Plot vector 1, vector 2. Magic. You see? Let me minimize. So this is the most used instruction to make a plot. Just 1 second. Now, another plot vector 1, vector 2, type equal line L. And let me go to the plot. Now it's a line connecting the points. Other instruction, arrow up, type equal B, both. Good. Let me try another option. If I am moving too quickly, stop me, please. Another option, type equal H. I'm not sure this option is correct. Let's see. It seems it is correct. Histogram. Another step, type both, call equal red, LWD equal 3. Who knows what happens? Let's see. First of all, I leave the instruction on the screen. LWD is the thickness of the line. Col is the color of points and line. We can make different colors for points and lines, but okay. So let me just tell you, if you put a question mark plot, here, select, let's select generics. Here it is. So the help is really long. And you see here that some of the options are described that we already used, like P for points, L for lines, B for both, C for the lines part alone of both, O for both overplotted, H for histogram, S for stair steps, no, N for no plotting. No plotting may be useful, I'll tell you later. Because at a first glance, you may say, no plotting, what is the purpose of it? The purpose is just to create the frame, and then you add the points, add the lines with other instructions. And you see that there are other options. The label of the axis, xlab, xlab, ylab, title and subtitle, many things. And also there is here something like, you see, 3 dots, several additional arguments, C, par, PAR. With this instruction, you can produce really high quality plots to give you, like in MATLAB, to give you an idea much better than Excel. There is no comparison. You can really produce high quality plots. of course, you have to learn a lot of things. So you have to study the help, you have to learn all the options that you may have. But indeed, they are high quality. And let me go back to R. And now, let's see the plot. What I wanted to do, I wanted to resize this window, but I don't think, because I'm not used to work in Windows, I don't think it is possible, because this is, yeah. So, one important thing, you may copy, you see here in the plotting, in the plot window, there is an icon with the camera, which means take a screenshot. This is possible. Another thing that you can do, because, I mean, you may want to save this plot. Usually we make a plot in order to use it. So another possibility is to use this function, dev to PDF, which means device to PDF. Device is, sorry, I don't remember the name of the function, so just 1 second. Copy to PDF, no? So I don't remember the name of the function. So let's go over Google. So copy, device, PDF, R project. Okay, it's dev to copy to PDF. So the function is this one. I go back. Dev dot copy to PDF. So you see that there is written Windows 2. And let's now go to my document directory, rplot. This is a new PDF. Let's double click over it. And this is my plot in Adobe Reader. No, it was open in the browser, but in any case, it's a PDF. So I copied my device over PDF, my plot over PDF. So now we learned in 1 hour to make basic operations, to save our workspace, to write a very simple function to make plots. So basically, we are almost ready to get a real exercise and to write a function to use it. Of course, it will be a learning by doing. There will be something that we need to do that we still don't know. And if you're interested, you can expand your knowledge by yourself, because I think you have all the means. And I think for today, that's fine. Questions? No questions. Let's the share, stop recording.